we're going to look at solving compound inequalities. Compound inequalities, it's the joining of two simple inequalities, and it can be joined by the phrase and, or it can be joined by the phrase or. And if we look at an and example, it might be something along the lines of, if you are ordering t-shirts for a camp, it's going to cost you $6.50 per t-shirt if you order between 20 and 40. So that's kind of a way we would write it using the word and. But now if we wanted to set this up using the actual inequality, I'm going to let T represent the number of t-shirts. And my inequality then would be 20 is less than, and depending on the rules for the company, it might have equal to there, T, which is going to be less than 40. So this is telling me that the number of t-shirts in order to get this price has to be between 20 and 40. We also have the inequality or, and the or inequalities will have the word or actually in the inequality. So like this one right here didn't actually physically have the and in it when we wrote it out in symbols. An or will have it. And an example might be getting a speeding ticket. Let's say you're on a divided highway and the minimum speed is 45 miles per hour and your maximum speed is 70 miles per hour. Well, you might be asking yourself, okay, at what speeds will you get a ticket? And with this one, since our minimum speed is 45 miles per hour, that means I'm going to get a ticket, or I could get a ticket, if my speed was less than 45 miles per hour. So if I'm going less than 45 on this interstate or this highway, I could get a ticket. Or there's another place I could get a ticket. Or if my speed is bigger than 70 miles per hour, I could also get a ticket. Now the reason we can't write this one as an and is because you have to ask yourself, can you be going slower than 45 and faster than 70 at the exact same time? And the answer to that is no. It's one or the other. If we come up here, the reason this one is an and is because can you be bigger than 20 while at the same time being smaller than 40? And the answer would be yes. Anything like in the 30s would fall into that category. So our ands and our ors have two different setups when we write them in symbols. Okay, here's our first practice. Solve and graph each of these. First thing we're going to do is we're going to solve them. And when you're solving a compound inequality, it is the exact same rules for solving a regular inequality, except for now you have to do it to all three locations when we have an and. So since I'm trying to get x by itself, the first thing I have to do is to subtract off 7. Well, now instead of just subtracting off 7 also from the left side, I have to do it on the right side too, because I have three different portions of my expression, so I have to do it to all three spots. -6 minus 7 is -13. I didn't multiply or divide by a negative, don't forget about that rule. Over here, my 7's cancel out to 0, so I'm just left with x. And on the right side here, 1 minus 7 would give you a -6. I've got x by itself, so this would be my inequality. Now this one is an and because it's written all together as one expression, and your inequalities are facing the same direction. It is not okay to write something like with our or example. We cannot write a single inequality to represent this. So I couldn't write it like this, that 45 is greater than s, which is less than 70, because I have two different symbols in here, and that's not acceptable because that would also be kind of an indication that 45 should be less than 70 also because it's on that side. So this is not legal to do, which is why this one has to be an and. We can be less than -6 but bigger than -13 at the exact same time. Now when I go down here to graph this, I graph it almost like it's two separate inequalities. So I'm going to do this part first. So I'm going to go down here to negative 13, and I want x to be bigger than negative 13. That means I have an open circle, and I'm going to start shading to the right. Now when you're doing compound inequalities, don't get carried away and go all the way to the arrow yet, because with a compound inequality we have to fulfill two requirements. I have to be bigger than negative 13 and at the same time be less than negative 6. So if I put negative 6 here, since it's less than or equal, I would have a solid circle, and I want numbers that are smaller than negative 6, so that means I'm going to go to the left. Notice I run into my other dot that I had over here. That's kind of my cutoff points. With an and, you have to be in between these two. I do not shade farther to the right and I do not shade farther to the left. I stop. And you shade just in between them. Okay, the second one. We're going to start with the same thing. I've got only one variable here, so I'm going to go ahead and get rid of this 8 by subtracting it. And again, I have to subtract it on all three spots. So negative 2 minus that 8 gives me a negative 10. Those two cancel out to be a 0, so I'm left with negative 3t. And over here, 10 minus 8 gives me a 2. Then I'm going to divide by negative 3, and I have to divide by negative 3 on all the spots. Right here, we have to flip those signs because I'm dividing by a negative. I'm just going to leave minus fractions. So negative 10 divided by negative 3 is just 10/3. Now instead of the less than sign, I have got to switch it to the greater than sign. My 3's there cancel out, so I'm left with t. And this sign gets switched also because I'm dividing by a negative here. So it's also going to turn into a greater than sign, and I'm going to be left with negative 2/3. Now I've got my t by itself, so I have my inequality here. When I go down to graph this, 10/3, that's 3 1/3. So I'm going to put the 3 right there, 4 right here. So 3 1/3 is going to be about there. I want it to be an open circle because it doesn't have the equal to part for my inequality. And then I want the values of t to be smaller than the 10/3. So I'm going to shade to the smaller, to the left side. Over here, I'm going to go down to my negative 2/3. And that's going to put me at about right here. It's going to be an open circle also, because it doesn't have the equal to part. And now I just look at this half of my inequality. T is greater than negative 2/3, so I want numbers bigger than negative 2/3. And again, I'm shaded towards the middle. Whenever you have an and inequality, your shading should turn out to be towards the middle. Okay, second set. Solve and graph each. Now notice both of these are or compound inequalities. So my first one is x is less than negative 1 or x is greater than or equal to 3. I don't actually have to solve either of these because x is completely by itself already. So I just need to go down to my graph and graph them. When I do this first one, I do them separately. I want x to be less than negative 1. Open circle, I want numbers less than negative 1, so that's shading to the left. Or x needs to be greater than or equal to 3. So closed circle on the 3, and I want numbers bigger than it. Notice these two, they are going away from each other. So now I need to shade those arrows. Okay, go ahead and pause the video and see if you can get this second one figured out. Alright, the first thing I did was I chose to do the left half first. Now with an or, they're separate. They're totally separate. So you solve it just like a regular inequality. Subtract 3 from both sides, divide by 2. I don't need to flip the sign because I wasn't dividing by a negative, and I got x is less than 1. Then I go over to my next inequality. Add 7, divide both sides by 4, and I get x is greater than 4. So now my inequality is x is less than 1 or x is greater than 4. When I go down to graph it, I graph them on the same number line, one at a time. So I open circle at 1, and I wanted values smaller than that, so I shaded left. And then open circle at 4, and I wanted values greater than that, so I had to shade to the right. Alright, here's our last one. It says, your coach tells you that soccer practice will be canceled if the temperature is above 31 degrees Celsius or if it's below 7 degrees Celsius. Write an inequality to represent the situation. Then use your inequality in the conversion formula, C equals 5/9 times the quantity F minus 32, to write the inequality in terms of degree Fahrenheit. So we have two separate things going on here. The first one says, write an inequality to represent the situation. Well, what I'm interested in is the temperature. And we're going to stick in degrees Celsius for the first one. So I know it tells me that if the temperature is above 31. So if my temperature is greater than 31 degrees Celsius, I get practice canceled. If my temperature is below 7, so I want my temperature to be less than 7 degrees Celsius. Now what we have to decide is, are we going to write this as an and or an or? So ask yourself the question, can your temperature be greater than 31 degrees while at the exact same time being less than 7 degrees? The answer to that is no, they cannot happen at the same time. That makes this an or inequality. So now I'm going to rewrite them as a compound inequality. My temperature needs to be less than 7 degrees Celsius, or my temperature needs to be greater than 31 degrees Celsius. So that takes care of the first part of it. Now the next part of it says, use your inequality and the conversion formula that Celsius is equal to 5/9 times your Fahrenheit temperature minus 32 to write the inequality in terms of degrees Fahrenheit. So what it's really asking us there is our temperature here is really a Celsius degree reading. That's like our C in our formula. So what we need to do is we need to replace that C with 5/9 times F minus 32 is less than 7, or, and again our temperature, that's our Celsius degree reading, so we're going to replace that T with our C equation, and then add on is the greater than to 31 degrees Celsius. From here we're going to solve each side of our inequality. I need to multiply by 9/5 on both sides, and when I do that over here, those cancel out, so I'm left with F minus 32 is equal to, well, when you take 7 times 9/5, you get about 12.6. Then I need to add 32 to both sides in order to get rid of that minus 32. Takes you up to 44.6. So my Fahrenheit, oops, that should be a less than symbol right there. So if my Fahrenheit is less than 44.6 degrees, practice will be canceled. Now do the same thing over here. I need to multiply both sides by 9/5, and when I do that, I end up getting 55.8. This side cancels out, so I'm left with F minus 32 is greater than 55.8. Again, add that 32 over, and on the left side I'm going to be just left with the F because my 32's cancel each other out, and on the right side I'm going to have 87.8 degrees Fahrenheit. So now my inequality in terms of Fahrenheit looks like that.